In this tutorial, we will see how to perform an advanced type electrical configuration. First of all, let's analyze the project that has been carried out. We have a building with a shed roof, made up of 7 pitches, and an east-west system, positioned on a building with 4 pitches. It is necessary that, as always, before moving on to the electrical part, the simulation of the shading has already been performed. Once this important step has been completed, it is possible to move on to the electrical configuration by clicking on the inverter icon. Under the first box of the inverters, we find all the fields that we have created. The 7 pitches relating to the shed building, the west pitch, and the east pitch. These are all the areas that we have made up by placing panels on top of them. To get started, we need to indicate which areas we want to include in the same configuration. As a first configuration, we are going to create a dimensioning that covers all the slopes of the shed building. To do this, we can click on Merge Similar Fields and select all fields that are similar to each other, i.e. all these areas. By activating Merge Similar Fields, the system creates a single field that contains them all. This is possible because, although the panels are arranged on different pitches, these pitches all have the same azimuth and all the same tilt, and therefore can be treated as a single field. As you can see, in fact, it is not possible to combine the west and east pitches in the same group, because they have different azimuths and tilts. Once all the layers have been selected, we can decide whether to use a system of optimizers. Here we have the power filter of the inverter, the 3-phase or single-phase network, neutral phase, 230 volts. Once we have correctly set all the filters, we can click on Next. At this point, since we have chosen to use a system of optimizers, inSun shows us the catalogs of optimizers available. We will use the TGO optimizers and select one of their products. At this stage, we have 2 solutions. We can apply them selectively, indicating the percentage of shading, below which we will apply real optimizers, while on the most irradiated modules, only a control device will be placed. Or we can also decide to set optimization systems on all panels, by clicking on Complete. In this case, we will use the selective type. We will place the optimizers on modules with a percentage of irradiation less than, or equal to, 95%. Apply. From the scene we see that on the modules with irradiation greater than 95%, red devices have been positioned, therefore energy flow control devices. On those with lower irradiation, power optimizers are placed instead. Completed the positioning of the optimizers. Click on Next. Now let's see the catalogs of the inverters, and we can choose the one that interests us most. The pitches that we have selected have a total of 210 modules, for a full power of 75.6 kilowatts peak. Having to satisfy 75 kilowatts, we could think of using 3 inverters of 25 kilowatts. Let's then select a suitable inverter, and click on Calculate. The system suggests the appropriate number of inverters to use. Confirm. We can see that now, up here, we will not have listed every single selected pitch, but simply, united fields. Therefore all the modules that we have placed on the pitches are treated as if they were a single field. We can now perform the automatic calculation. You see that the system places all 210 panels, creating strings of 17, 14, and 19 modules. This assignment can obviously be changed. For example, if we wanted to have strings of 18 modules here, we could select 36 and 36. In the same way, we can go to make these strings more uniform as well, 32 and 30. Always, however, satisfying the entire number of modules. Once we are satisfied with the configuration we have created, we can click on Apply to Fields. At this point, inSun shows us, here on the right, the electrical configuration created. Then the 3 inverters, with 2 MPPT each. We could now decide to place some string boxes. It will be sufficient to click on an inverter, and then check how many strings flow into an MPPT. In this case, we have two strings that converge in an MPPT, and therefore we may need a field frame with two inputs and one output. Here we see all the catalogs of string boxes. This might be fine, as it has two inputs and one output. Assign. The thunder icon means that the system has loaded a string box for each MPPT. With the same procedure, we can assign it to the other inverters as well. Once we have completed the assignment of the field panels, we can place the inverters on the scene. We click on the magic wand, select the first inverter, and drag it where we deem it appropriate. Let's take the second inverter as well, and drag it to the scene. Finally, we select the third inverter, and also place this on the wall. At this point, we can click on Assign All Fields. This is the scheme created by the system. If we are satisfied, we can save the configuration. Let's go now to rename it. We will call it Shed Configuration. Once this electrical part is finished, we can proceed to another building with a new electrical configuration. Let's open the inverters again, and select the east pitch field and the west pitch field, this time separately from each other, and therefore without activating merge similar fields. This is because the fields have different azimuth and tilt values, and therefore should be treated as two separate fields. At this point, we can go and adjust the filters according to our needs. Go to Inverters. Let's now see the catalog of inverters. This time we have 23.04 kilowatts peak, and so a 20 kilowatt inverter will probably be enough. Let's select it. The important thing to take into consideration is that we now have two fields that cannot be merged. Therefore, we will necessarily need at least two MPPTs to manage the system. This inverter has two MPPTs, so we can proceed to calculate the strings. Recommended number of inverters, 1. Confirm. Up here, we can see the east and west pitch fields, separated from each other, and both with 32 modules. At this point, we have to assign the two layers, each to an MPPT. Here we have the inverter 1, our only inverter, divided into its two MPPTs. To the first MPPT, we will assign the east slope. To the second, the west slope. We can assign the 32 panels of the east pitch to the first MPPT, and the 32 of the west pitch to the second. Once all the modules are satisfied, click on Apply to Fields. Here, we can see the new electrical configuration. This time, we do not want to use string boxes, and therefore, we move directly to the positioning of the inverter. We select it, and we drag it into the scene. Assign all fields. If the graph does not satisfy us, we can intervene on the drop point, and go to modify it. In this case, the system has brought all the cables to the opposite side of the inverter. By modifying the drop point, we can place the cables in the correct position, in this case on this ridge. Assign all fields. Here is that the system offers us a graph that is certainly more ordered. Save configuration.